Welcome to This Explainer. Today, we're diving straight into a real-life scientific detective story. We're looking at the measurement mystery of why our oceans are accelerating. Now, for decades, sea level rise has been one of the most obvious, undeniable results of climate change. But behind the scenes, scientists have actually been wrestling with a super frustrating puzzle. Basically, the numbers just weren't adding up. But today, we're unpacking a massive breakthrough by an international team of researchers who finally cracked the case. They've closed the global sea level budget and figured out exactly why our oceans are rising faster than ever. To really grasp what we're up against, let's put the raw data into perspective. Historically, so from 1960 onwards, global sea levels were rising at an average of 2.06 millimeters per year. But jump to our modern era, specifically between 2005 and 2023, and that pace has skyrocketed to 3.94 millimeters a year. Literally, the rate of sea level rise has nearly doubled in just a few decades. It's a stark contrast, and it absolutely underscores the severity of the threat we're facing. We had to figure out the mechanics behind this massive acceleration. Section 1. A lingering measurement mystery. So, we knew the waters were rising, right? But for the longest time, scientists were dealing with this glaring discrepancy. Simply put, why didn't the math add up? It was kind of like balancing a checkbook and always being off, but having no idea why. On one hand, you had the actual observed sea level rise from high-tech satellites and coastal tide gauges. But on the other hand, you had the calculated estimates from known causes, like ocean expansion and melting ice. And the really frustrating part? These two columns of data just did not align. You can actually feel the frustration from the scientists themselves. Professor John Abraham, a co-author of this landmark study from the University of St. Thomas, hit the nail on the head. He said, for years, there has been a frustrating gap between how much the oceans were observed to be rising and how much we could explain from the individual causes. But, as the rest of his quote reveals, there's finally some good news. He adds, this work shows that, with better instruments, processes, and smarter analysis, this knowledge gap can be closed. And fortunately, that gap is now officially closed. An international team led by scientists from the Chinese Academy of Sciences, working with partners in France and the US, finally solved the discrepancy. And they did it using three major technological improvements. First, they applied updated corrections to satellite measurements that had kind of shifted after 2015. Second, they got way better at tracking how the actual coastal land moves around tide gauges. And third, they finally nailed down highly accurate estimates of exactly how much ice was pouring out of Greenland and Antarctica. By fixing those three inputs, boom, the math finally worked. Section 2. The true causes revealed. Okay, so now that the gap is resolved, closing what scientists call the sea level budget, the observations perfectly match the causes. So what exactly is driving this? Well, the biggest culprit might surprise you. It's warming oceans, responsible for 43% of the total increase. As seawater heats up, it literally expands and takes up more space. Then you've got melting mountain glaciers at 27%. The Greenland ice sheet adds 15%, Antarctica brings in 12%, and changes in land water storage round it out at 3%. When you add up the glaciers and those two giant ice sheets, melting ice is a totally dominant factor here. Geographically, it really helps to picture where all this is happening. Right in the middle of the system, you have that massive 43% chunk caused simply by the global ocean basin holding more heat and expanding. And then, pouring into the system from the very edges of our planet, you've got the mountain glaciers and the colossal ice sheets of Greenland and Antarctica. We're not just talking about abstract numbers here. These are massive physical transformations happening at the polar extremes and high altitudes, all pouring directly into our oceans. But here's where it gets really interesting. The study didn't just pinpoint the causes, it showed us how those causes have shifted over time. Before 1993, the major drivers were just ocean warming and changes in land water storage. But after 1993, the story changes completely. The rapid melting of glaciers and ice sheets, especially in Greenland and Antarctica, suddenly became a much larger driver. Basically, the ice is melting way faster than it used to, and that specific shift is exactly what's pushing that modern acceleration trend we talked about at the start. Section 3, the reality of planetary inertia. So, we have a perfectly clear picture of the past 6 decades now. But these findings bring us to a pretty sobering conclusion about our future. It all boils down to a concept called enormous planetary inertia. Researchers are warning us that even if we magically stabilized all greenhouse gas emissions tomorrow, sea level rise isn't going to just stop. Why?
because the Earth's oceans are so incredibly vast that they absorb heat very, very slowly. They're going to keep warming deep below the surface for a long time. Plus, all those massive ice sheets are going to keep melting long after temperatures stabilize. There is just so much built-in momentum that scientists expect sea levels to keep rising for centuries.
The measurement mystery is totally solved. The math works, and it perfectly explains what our coastlines are experiencing right now. But it leaves us with an absolutely massive challenge. If the oceans carry this enormous planetary inertia, and we know for a fact they'll continue to rise for centuries to come, how will our coastal cities and vulnerable communities adapt to this unstoppable momentum? It's a huge question that demands our attention right now. Thanks so much for joining me for this explainer, and I hope it leaves you eager to learn more.